A solid iron pillar has stood in the open air for 1600 years without rusting away. This is the Delhi Iron Pillar, an ancient marvel that silently challenges everything we think we know about technological history. By the end of this, you will see a single object as a key that can unlock a forgotten chapter of human genius. How did 5th century metalworkers create something modern science still struggles to fully explain? And what profound truth does its survival reveal about the story of progress itself? What does true mastery over the physical world actually look like? That polished surface tells a silent story of defiance. To appreciate just how deep this mystery runs, we need to understand what should have happened to it. Think about an old bicycle left out in the rain, or a forgotten tool in a damp shed. Within a season or two, that reddish-brown corrosion begins to bloom, a flaky crust that steadily eats away at the metal until it becomes weak and brittle. This process, the relentless transformation of iron into rust when exposed to air and moisture, is one of the most fundamental chemical reactions we know. It is so predictable, so universal, that our entire modern infrastructure is built around a constant battle against it. We paint bridges, we galvanize steel, we design alloys, all in a costly, endless war to delay the inevitable. The Delhi Pillar did not get the memo. For over 1,600 years, it has withstood not just the mild elements, but the full force of the North Indian climate. Scorching summer heat gives way to torrential monsoon rains, with humidity that can make the air itself feel thick. This cycle, repeated annually for centuries, is a perfect recipe for rapid corrosion. Yet the pillar stands. Its surface is smooth, bearing only a dark, stable patina and the elegant lines of its ancient Sanskrit inscription. This is not a case of slow decay. It is a case of near-perfect preservation. The first and most profound question it poses is not how it was made, but why it has not undone itself. This visible, physical enigma is what pulls scientists and historians closer, inviting them to look beyond the surface and into the very heart of the metal. That dark patina holds more than just chemical secrets. It holds centuries of human history. To truly grasp the scale of its defiance, we must see it not as a static monument, but as a silent witness that has watched empires bloom and fade around it. Most scholars agree the pillar was forged and first erected somewhere around the year 400, during the golden age of the Gupta Empire. This was a period of extraordinary advancement in India, a flourishing of art, science, mathematics, and literature. The pillar was likely commissioned by a powerful Gupta king, perhaps the second, and originally stood in a temple complex, possibly in the ancient city of. It was not just an engineering feat, it was a statement. The beautifully crafted Sanskrit verses that run along its surface sing praises of a ruler named, celebrating his victories in battle and his devotion. It served as a towering axis linking earthly power to the divine, most likely dedicated to the god Vishnu, the preserver of the universe. There is a profound irony in that dedication, for preservation is exactly what this pillar has mastered in a most literal, physical sense. Its story, however, was only beginning. Centuries after its creation, the political landscape transformed. Following Islamic conquests in the region around the 12th century, the pillar was carefully uprooted from its original home and transported to its current location in what is now Delhi. There, it was re-erected within the courtyard of the Islam Mosque, part of the growing complex. This journey is a pivotal part of its mystery. It was not destroyed or melted down for scrap, as so many symbols of prior regimes were. Instead, it was preserved, integrated into a new architectural narrative. This tells us that even those who moved it recognized it as an object of extraordinary, perhaps inexplicable quality. Think of that journey, the logistics of moving a 23-foot tall, 6-ton solid iron column in an age before mechanized transport. It would have been a monumental effort, undertaken only for something deemed uniquely valuable. This pillar, therefore, carries two layers of miracle. The first is the metallurgical genius of its creation. The second is the sheer historical fortune of its survival, passing through the hands of different cultures and faiths, each choosing to let it stand. Its longevity asks a quiet but insistent question. What did its original Gupta-era creators know about the nature of iron that allowed them to produce something so timeless? And how did that knowledge slip from the pages of history? The pillar's survival through history is one miracle, but the secret of its physical defiance is another. To solve that, we must look inward, past its dark patina, and into the very structure of the metal itself. For a long time, the pillar's rust-proof nature was a matter of legend and speculation. Some suggested it was made from a meteorite, a gift from the stars with otherworldly properties. Others believed it was protected by a lost chemical treatment or even a divine blessing. Modern science, however, has given us the tools to see what the naked eye cannot. Using invasive techniques like X-ray fluorescence, researchers have mapped the pillar's elemental makeup without harming it. What they found was both astonishing and elegantly simple. The Delhi iron pillar is not a complex modern alloy. It is made of wrought iron, a material known for centuries, forged in a traditional way. But its specific recipe is where the genius lies. This is not just any wrought iron. Its composition reveals two critical and somewhat counterintuitive facts. First, it has an exceptionally low carbon content, typically below 0.25%. This makes it softer and more malleable than steel, which gains strength from higher carbon. Second, and far more importantly, it has a remarkably high phosphorus content, around 0.25%. In modern metallurgy, phosphorus is considered an impurity. In high-quality steel production, we work tirelessly to remove it because it can make metal brittle and prone to cracking under stress. So why would the Gupta-era metalworkers, who clearly possessed immense skill, intentionally create a high-phosphorus iron? The answer is not a mistake, but a masterful trade-off. They were not building a sword or a spring that needed to withstand sudden impact. They were building a monumental pillar meant to stand for eternity. The high phosphorus, combined with the specific process of repeated heating and hammering, did something extraordinary. As the iron was forged, the phosphorus became unevenly distributed. It encouraged the formation of a unique, stable compound called iron hydrogen phosphate within the metal's microstructure. This compound, along with the slag particles from the forging process, creates a passive, protective film on the surface when exposed to the atmosphere. Think of it not as a coating applied later like paint, but as a skin that the metal grows itself. This skin is dense, adherent, and porous. When the monsoon rains hit the pillar, this film prevents moisture and oxygen from penetrating deeply into the metal and the destructive cycle of rust. The ancient artisans, through a combination of carefully selected raw materials and a meticulous physical forging process, essentially programmed the iron to protect itself. They turn what we see as an impurity into the cornerstone of immortality. This shifts our perspective entirely. The pillar is not rust-proof despite being ancient. It is rust-proof because of the specific, brilliant choices made in its ancient creation. So the first key is now in our hands. The material itself is the guardian, but this only deepens the next layer of the puzzle. How could artisans of the 5th century achieve such precise control over chemistry and process? And why did this pinnacle of knowledge seemingly vanish after them? This invisible shield is where modern science finally meets ancient craftsmanship. The leading explanation for the pillar's defiance is something called a passive film. Picture the hardest, most durable stick pan you have ever seen. That slick surface does not just happen. It is engineered at a microscopic level to create a barrier so smooth and inert that nothing can grab onto it. The Delhi pillar has done something remarkably similar, but it built its own protective layer over centuries. This film is not something applied from the outside, like a coat of paint. It is a skin that grew from within, a direct result of that unique high-phosphorus iron reacting patiently with the very elements that should destroy it. When the first monsoon rains fell on the newly forged pillar, a slow, profound alchemy began. The phosphorus in the metal, interacting with moisture and oxygen from the air, catalyzed the formation of specific compounds, primarily one called iron hydrogen phosphate hydrate. This is the magic ingredient. Unlike common rust, which is like a brittle, flaky scab that cracks and lets the infection go deeper. This compound forms a film that is incredibly dense and tightly bound to the metal beneath. It is not a flaw, it is a flawless seal. Once this thin, stable layer covers the surface, it actually prevents further oxygen and water from penetrating. It slams the door on the corrosion process. Even more remarkably, if this film is lightly scratched or worn, the ongoing environmental conditions help it reform and heal itself. This is not a static coating. It is a living, self-maintaining barrier. The staggering implication is that the Gupta-era metalworkers, whether by profound intuition or meticulous experimentation, engineered this property into the heart of the metal. They did not fight nature's tendency to corrode iron, they cleverly guided it toward a different, stable outcome. They harnessed chemistry to create a perpetual guardian. This concept of a passive film is a cornerstone of modern corrosion science. We use it today when we rely on the protective oxide layer on stainless steel or aluminum. To find it fully realized in a 1600-year-old monument is not just surprising, it is humbling. It suggests a branch of material science that was cultivated, reached a dazzling peak, and then, like the pillar itself, was left standing alone in the historical record. So we have the what, and we have the brilliant how. But this only makes the next question burn brighter. If they possessed knowledge so advanced it echoes our own, how did they actually forge this 6-ton marvel? And what does that forgotten process reveal about the true scale of their industrial world? The pillar's self-healing skin is a masterpiece of ancient engineering, but even the best design needs the right environment to thrive. Here lies a beautiful paradox. The very climate of Delhi, with its punishing extremes, may have been the pillar's greatest and most unlikely ally. This is not a story of an object merely enduring its surroundings, but of finding a profound, accidental harmony with them. The theory is elegant. The cycle of dry, scorching heat followed by intense monsoon humidity did not attack the pillar. It instead created the perfect conditions to maintain that protective passive film. Think of it like a natural maintenance schedule. The seasonal rains provide the moisture needed for the slow, ongoing chemical reactions that keep the iron hydrogen phosphate film stable and adherent. This is the wet phase, where the film subtly renews itself. Then, the long, hot, dry season arrives. This period is equally crucial. It allows the surface to dry thoroughly, preventing the constant, soggy exposure that could lead to a different, more destructive type of corrosion. The dry heat essentially bakes and solidifies the protective layer, locking it in place until the next cycle begins. It is a rhythmic dance between the metal and the atmosphere, a partnership forged over centuries. Without this specific cycle, the film might not have formed so perfectly or lasted so long. In a perpetually wet climate, the film could be leached away. In a perpetually dry one, it might never have formed with such strength. This environmental synergy hints at something profound. The pillar's survival is not just a product of Gupta genius in a vacuum. It is the result of that genius interacting with a specific place on Earth. Its location in Delhi may be far more than incidental. It presents a captivating idea that a man-made object, through its extraordinary internal design, found a perfect ecological niche in the weather patterns of northern India. The pillar did not just stand against nature. It learned to work with it, turning potential adversaries into partners in its own preservation. This shifts our understanding from a solitary marvel to a symbiotic relationship, a dialogue between human creation and the natural world that has lasted for 16 centuries. But this harmony only deepens the central mystery. If the environment was a willing partner, what does that say about the knowledge of the people who placed it here? Did they understand this synergy? Or was it a breathtaking stroke of fortune, yet this profound harmony with the environment only sharpens the central question of its origin? To forge such a perfect object required not just knowledge, but a physical feat of almost unimaginable scale. We must step back into the heat and roar of a 5th-century workshop. The artisans, known as, did not have the luxury of modern blast furnaces or electric forges. Their primary tool was the bloomery furnace, a simple clay or stone structure fueled by charcoal. Inside, iron ore and charcoal burned together in a carefully managed fire. The chemical reaction would pull oxygen from the ore, but the temperatures were not high enough to melt the iron completely. Instead, it produced a spongy, glowing mass of metal mixed with rocky waste material called slag. This was the bloom, the raw, impure heart of the process. Extracting this searing hot mass was only the beginning. The real magic and the backbreaking work happened at the anvil. The glowing bloom would be repeatedly heated, then hammered by teams of smiths. With each thunderous blow, liquid slag would be squeezed out like water from a sponge, and the particles of pure iron would weld together into a denser, more solid mass. This was the art of forge welding, the foundational skill of all ancient ironwork. Now, consider the scale of the pillar. It weighs over 6 tons. To create a single, seamless piece of that size from small blooms was likely impossible. Historians and metallurgists believe the pillar was almost certainly built up through a series of massive, successive welds. Imagine this. A team of master smiths would first forge a colossal cylinder, perhaps a few feet long and weighing hundreds of pounds. While it was still white-hot, they would bring another freshly forged cylinder of identical composition into perfect contact. Then with precise, coordinated hammering, they would fuse the two into one solid piece. This process would be repeated over and over, welding section to section in a vertical chain until the full 23-foot column was born. The sheer coordination required is staggering. Every weld had to be perfect, with no weak points, no pockets of slag that could become sites for future corrosion. Even more astonishing is the consistency. Scientific analysis shows the phosphorus content is remarkably uniform throughout the entire pillar. This tells us they were not just strong, they were impeccably controlled. They had mastered their raw materials and their process to such a degree that they could replicate the same chemical recipe in bloom after bloom, weld after weld, creating a homogeneous giant from countless smaller pieces. This was not a happy accident. It was the result of a sophisticated, standardized, and likely generations-old production system. The pillar stands as a silent testament to an entire ecosystem of knowledge, from the miners who selected the ore, to the charcoal makers who managed the fuel, to the master smiths who directed the symphony of hammers. Their achievement forces us to ask, if they could do this 1,600 years ago, what else did they know that history has simply forgotten? The thunderous rhythm of those ancient hammers leaves us with a profound silence. We can reconstruct the how, the physical act of creation, but the why remains shrouded in the smoke of the forge. This brings us to the central, haunting debate that divides historians and captivates anyone who stands before the pillar. Was its legendary rust, resistance a stroke of intentional genius, or simply a magnificent accident? The answer we choose reshapes our entire view of ancient science. On one side of this divide are those who see a deliberate recipe. The evidence they point to is the pillar's remarkable consistency. Its phosphorus content is not just high, it is uniformly high throughout its entire 6-ton mass. In a piece forged from dozens, perhaps hundreds of individual blooms welded together, achieving such chemical uniformity is no small feat. It suggests a controlled, repeatable process. The artisans were not just grabbing ore from any nearby source, they were selectively using a specific type of ore, and they were processing it in a specific, disciplined way to preserve that phosphorus content. To these scholars, this level of control points to a developed metallurgical tradition. It implies that the Gupta period had, through generations of observation and experimentation, identified a link between certain ores, their forging methods, and the long-term durability of the final product. They may not have had the periodic table or the language of passive films, but they possessed a deep, practical wisdom. They knew that iron made this way lasted. The pillar, then, is not a lucky one-off. It is the pinnacle of a sophisticated craft, a testament to a school of knowledge that was later lost. The opposing view offers a more humble, yet equally fascinating, interpretation. Perhaps the smiths were not thinking about corrosion at all. Their primary goal was to create a monumental, structurally sound column that could support a heavy ceremonial finial and to inscribe it beautifully. The local ore bodies available to them, particularly from the region of modern-day Bihar, are naturally rich in phosphorus. They simply used the best material they had. The high phosphorus made the iron easier to forge weld at their available temperatures, a practical benefit they would have immediately appreciated. The incredible rust resistance, according to this theory, was a secondary property, a wonderful side effect they witnessed over time but did not engineer from the start. In this light, the artisans were supreme masters of their art, but not necessarily theorists of its chemistry. They worked with an intuitive feel for their materials, achieving perfection through practiced skill rather than through a formal understanding of underlying principles. This debate touches on something fundamental about how innovation happens. It asks whether true technological insight requires conscious design, or if it can emerge from the relentless pursuit of excellence within a craft. Both possibilities are deeply human. The first speaks to our drive to understand and control our world. The second speaks to our ability to achieve sublime results through accumulated experience, even when the full explanation eludes us. The Delhi pillar, in its silent endurance, supports both narratives. Its consistent composition argues for deliberate choice. Yet the complete absence of any other similar pillars or any textual records detailing this rust-proofing technique could suggest the knowledge was situational, tied to that specific ore and place, and never fully systematized. So, were they brilliant chemists or the world's most fortunate artisans? The pillar refuses to say, and perhaps that is the point. Its mystery forces us to confront the limits of our own historical perspective. We live in an age of explicit, documented science. We expect innovation to be a conscious, recorded act. The pillar reminds us that profound mastery can exist in a different form, one where the deepest understanding is embedded not in scrolls, but in the hands of the smith, the choice of the ore, and the rhythm of the hammer. It challenges us to expand our definition of knowledge itself. But this unresolved question only leads to a larger, more unsettling one. If this was indeed a peak of lost science, what happened? How does knowledge of such power simply fade from the world, leaving only a single, silent sentinel as its proof the silence of the pillar's unanswered questions echoes across the world? To truly measure its achievement, we must step outside of Delhi and place it on a global stage. For centuries, other great civilizations also mastered iron. The Romans forged the mighty, the javelin that built their empire. The Chinese, during the Han Dynasty, produced cast iron on an industrial scale, creating intricate tools and artwork. Across Africa, skilled smiths in places like the culture created sophisticated iron implements long before European contact. These are all testaments to human ingenuity, yet they share a common, telling fate. Almost without exception, the ancient iron objects we have today survived not because they the elements, but because they were spared from them. They were found buried in tombs, sealed in hoards, or preserved in the oxygen-free mud of riverbeds and bogs. These environments, known as anoxic, essentially put the metal into a state of suspended animation, protecting it from the corrosive kiss of air and water. Their survival is a story of archaeology, of fortunate burial. The Delhi pillar tells a completely different story. Its survival is a story of material science. It did not need to be buried to be saved. It has spent every single day of its 1600-year life fully exposed, breathing the same humid air, feeling the same monsoon rains, baking under the same sun as everything around it. While other artifacts were sleeping safely underground, the pillar was wide awake in the storm, and it did not rust. This distinction is everything. It isolates the pillar's achievement not as a matter of luck or preservation, but as a fundamental property engineered into its very being. When we line it up beside other ancient iron marvels, it stands alone. It suggests the Gupta metalworkers did not just perfect a craft, They discovered a specific technological pathway, a recipe and a process that yielded a result so durable it appears as an anomaly in the historical record. This raises a profound possibility. Was this knowledge a brilliant, localized breakthrough that never spread beyond its cultural context? Or was it a glimpse of a potential future for metallurgy, a branch of science that bloomed magnificently, and then, for reasons we may never know, was pruned from the tree of human knowledge? The pillar, in its solitary defiance, forces us to wonder how many other peaks of ancient understanding have been lost to time, leaving no monument at all. But the pillar's story is not told by chemistry alone. It also speaks through words, carefully etched into its iron skin. Running vertically along its surface is an inscription in classical Sanskrit, a poetic eulogy that has survived as perfectly as the metal it is carved into. This is not a simple label or a builder's mark. It is a work of art and propaganda, a declaration meant to echo through the centuries. The verses sing the praises of a mighty king referred to simply as a name that scholars widely associate with the Gupta Emperor II, who ruled around the turn of the 5th century. The language is ornate and powerful, celebrating his military conquests that stretched across the Indian subcontinent, and more importantly, his deep devotion. The pillar, the inscription tells us, was erected in honor of the god Vishnu, on a hill named the Footprint of Vishnu. This single detail transforms our understanding of the object. It was not merely a civic monument or a victory column in a secular sense. It was a stambha, a flagstaff or standard, meant to stand before a temple. It served as a physical axis linking the earthly kingdom to the divine order, a permanent reminder that the king's authority was sanctioned by the preserver of the universe himself. The choice of material now takes on a profound symbolic weight. To commission, a monument meant to last for eternity in service to an eternal God, what material could be more fitting than iron that itself time? The inscription reveals a society operating at a breathtaking convergence of ideals. Here, artistic expression through sublime poetry, political power through royal glorification, religious fervor through devotional acts, and scientific ambition through material mastery were not separate pursuits. They were woven together into a single, towering statement. The Gupta period, often called a golden age, was precisely this, a time when advancements in literature, mathematics, astronomy, and the arts flourished alongside each other. The pillar is the physical embodiment of that holistic genius. The care taken to inscribe such a lasting message implies a breathtaking confidence in the future. Those who carved these words into the hot iron believed, or perhaps knew, that their work would be read long after they were gone. They were not building for their own generation, they were building for us. This intent for legacy contextualizes the metallurgical achievement not as a happy accident or a purely utilitarian goal, but as a conscious, deliberate part of a grand cultural project. The rust-proof quality was not just a technical feature, it was a philosophical necessity. To create a symbol meant to carry a king's name and a god's praise across the ages, you needed a material that would not whisper, but shout its message across the centuries. The pillar succeeds because its form and its function, its material and its message, are in perfect, silent agreement. This fusion raises a poignant question for our own era. In our world of planned obsolescence and disposable technology, what would we build if we truly intended it to last for 1,600 years? And what story would we dare to etch upon it? The words carved into the pillar were meant for kings and gods, but its silent presence speaks a different language to the people who live beside it. Beyond the pages of history books and the graphs of scientific reports, the Delhi iron pillar has taken root in the rich soil of local imagination. For generations, its impossible durability has inspired stories that try to explain the unexplainable, weaving the iron giant into the fabric of folklore. One of the most enduring tales is a simple, hopeful ritual. It is said that if you can stand with your back to the pillar and manage to encircle its massive girth with your arms, your deepest wish will be granted. This is no easy feat, given the pillar's considerable diameter, and the tradition has created a visible, polished band around its base where countless hands have tried. This is not a story about metallurgy, it is a story about hope. The community transformed the pillar's physical challenge into a test of faith and a conduit for dreams, attributing to it a benevolent, magical power. Other legends go further back, suggesting the pillar was not forged by human hands at all, but was the divine staff of a mythical hero from the epic Mahabharata, left behind as a relic of a more legendary age. These narratives, while not factual in a historical sense, are profoundly true in a cultural one. They represent a universal human response to a mystery. When faced with an object that defies everyday understanding, that stands unyielding while empires and seasons turn to dust, the mind seeks a story. It reaches for myth to provide a framework that science at the time could not. The pillar's rust-proof nature was not just a chemical curiosity, it was a prompt for wonder. These local legends do not diminish the pillar's scientific significance, they enrich it. They add a living, breathing layer of meaning to the cold iron. They show us that the monument's impact was never limited to scholars or rulers. It belonged equally to the everyday person who looked up at it and sensed something extraordinary. The folklore is a testament to the object's emotional resonance, a cultural interpretation that ensured its story was passed down not only in inscriptions, but in whispered traditions and hopeful rituals. This blending of the tangible and the mythical makes the pillar a complete artifact. It exists simultaneously in three realms: the realm of verifiable science, the realm of recorded history, and the realm of enduring human wonder. Each layer asks a different kind of question, and together they form a more holistic picture of why this single object continues to captivate us. It challenges our laboratories, it fills our history books, and it stirs our innate desire for magic. This deep cultural embedding poses a final, reflective question. In our modern world, so focused on demystifying everything, have we lost the capacity to simply stand before a marvel, to feel the awe, and to let that wonder inspire its own kind of story? For 16 centuries, the pillar's secret was guarded by its own dark patina. Then came the 20th century, and with it, a new kind of curiosity armed with precision instruments. The ancient mystery was about to meet the modern laboratory. One of the first to bring rigorous science to the question was Sir Robert, a pioneering British metallurgist. In the early 1900s, he obtained a small sample from the pillar, a precious sliver of history. Using the cutting-edge tools of his day, primarily optical spectroscopy, he performed a careful chemical analysis. His findings were groundbreaking. He confirmed the iron was remarkably pure, with very low sulfur, but he also identified an element that should not have been there in such quantity: phosphorus. This was the first major clue, a chemical fingerprint that set the pillar apart from any known modern alloy of the time. His work shifted the conversation from folklore to forensic science. He demonstrated that the pillar's resistance was not magic, but a property rooted in its tangible, measurable composition. The door to understanding had been cracked open, but the view inside was still blurry. The true revolution in understanding would have to wait for another leap in technology. By the 1960s and 70s, science had gifted researchers tools that felt almost like time machines. Techniques like X-ray diffraction and scanning electron microscopy allowed them to see the metal in an entirely new way. They were no longer just identifying elements, they were mapping the invisible landscape of the pillar's soul. X-ray diffraction revealed the crystal structure of the metal, showing how the iron atoms were arranged. More importantly, it helped identify the specific compounds present on the surface. This is how the crucial compound, iron hydrogen phosphate, was conclusively identified as the hero of the story. Meanwhile, the electron microscope offered something even more astonishing: a visual map. For the first time, scientists could peer into the microstructure of the ancient iron at magnifications thousands of times greater than any optical microscope allowed. They could see the tiny slag particles, the grain boundaries, and most critically, the thin, unbroken film that sheathed the surface. They could observe how this passive layer was bonded to the metal beneath, and how it differed from the flaky, porous structure of common rust. Each investigation was like peeling back a layer of an ancient onion. The spectroscopic analysis gave them the recipe. The X-ray studies named the protective compound. The microscopic imaging showed the physical architecture of its defense. Piece by precise piece, the modern laboratory reconstructed the logic of the ancient forge. The pillar was transformed. It ceased to be merely an archaeological wonder and became a celebrated case study in advanced materials science. It provided a real-world, thousand-year test of corrosion theory that no modern experiment could ever replicate. In doing so, it built a profound bridge. On one side stood the intuitive, hands-on mastery of the Gupta, who knew their material through feel, sight, and tradition. On the other side stood the contemporary scientist, who knows it through spectra, diffraction patterns, and molecular models. The pillar proved that these two ways of knowing, though separated by vast gulfs of time and methodology, could arrive at the same breathtaking truth. The laboratory did not diminish the artisan's achievement. It validated it with a new language, allowing their silent genius to finally speak in the precise terms of modern understanding. Modern engineering could certainly build a pillar of iron, but could it build this one? The question of replication is a fascinating mirror held up to our own technological age. We now possess the pillar's complete chemical profile and a solid theory for its rust resistance. We have laboratories that can analyze its structure down to the atomic level. In theory, we know the recipe. Yet, the practical answer is a humbling and definitive not quite. Understanding a principle is not the same as recreating the unique historical artifact that embodies it. The first and perhaps greatest hurdle is the very foundation of the process, the raw material. Our modern steel industry is a marvel of efficiency and purity. We start with iron ore, but our entire refining process is engineered to remove impurities like phosphorus and sulfur to create consistent, high-strength steel. To replicate the Delhi pillar, we would have to do the exact opposite. We would need to seek out a specific, high-phosphorus ore or deliberately reintroduce phosphorus into pure iron, then process it not in a computerized electric arc furnace, but in a traditional bloomery. We would have to abandon a century of optimization for a path our industry considers a step backward. Then comes the forging. We could simulate the hand hammering, perhaps with modern hydraulic presses, but the exact sequence of heats, the specific force of each blow, the incorporation of slag particles, these are not variables we can program with precision. They are the embodied knowledge of the master smith, a feel for the metal that was cultivated over a lifetime and passed down through generations. We could approximate the form, but could we replicate the unique, self-healing microstructure that resulted from that specific physical dance between hammer, heat, and human intuition? Finally, there is the element of time itself. The pillar's perfect passive film is not a product of a week or a year in a climate chamber. It is the result of a 1600-year conversation with the Delhi environment. That specific cycle of monsoon and dry heat, repeated over centuries, gently coaxed the protective layer into being and matured it to perfection. We could accelerate aging in a lab, but we cannot compress the slow, patient partnership between the metal and its place in the world. A modern replica would be a fascinating specimen, a demonstration of our analytical understanding. But it would be a newborn, lacking the lived history that is integral to the original's identity. This distinction reveals something profound about different kinds of knowledge. The Gupta metalworkers possessed a deep, process-oriented mastery, a wisdom embedded in practice and material. We possess a deep, analytical mastery, a wisdom embedded in data and theory. The pillar stands at the crossroads, proving that both paths can lead to an astonishing destination. Our inability to perfectly copy it is not a failure of modern science. It is a testament to the irreplaceable context of history. It reminds us that some achievements are not just products of knowledge, but of a specific time, a specific place, and a specific conversation between human hands and the natural world that can never be fully restaged. So while we may never forge its twin, the attempt to understand it has gifted us something equally valuable, a new respect for the subtle, forgotten genius of the ancient world. Its chemical immortality is only half the story. The true weight of the Delhi Pillar's achievement is felt in the most literal sense, in the sheer physical burden it has carried for 16 centuries. This is not a delicate artifact kept in a climate-controlled case. It is a 23-foot-tall, 6-ton column of solid iron that has spent its life standing upright, supporting its own colossal mass against the constant pull of gravity. That alone is a profound test of material strength. But its environment has provided far more brutal examinations. Northern India is a seismically active region. Over its long life, the ground beneath the pillar has undoubtedly shuddered with earthquakes, some likely of significant force. For over a century, it has also endured the relentless, low-frequency vibrations from modern traffic rumbling past the complex. Through all of this, the pillar shows no signs of buckling, bending, or developing the structural cracks that would be the death sentence for any less perfectly made object. This flawless endurance reveals a second, parallel layer of mastery. The ancient were not just brilliant chemists, they were peerless structural engineers. They understood that creating a monument for the ages meant winning a war on two fronts, against both chemical decay and physical failure. The key to this structural triumph lies in the very quality of the wrought iron itself and the perfection of its assembly. We know the pillar was likely built up from many individual sections, each one forge welded to the next in a vertical chain. This welding process was the ultimate test of skill. Any flaw at the joint, any pocket of trapped slag, any incomplete fusion would create a weak point, a line of stress concentration. Under the immense, constant load of the pillar's own weight, amplified by the occasional shock of an earthquake, such a flaw would inevitably begin to propagate. A tiny crack would grow, slowly and inexorably, until the structure failed. The fact that no such failure has occurred in over a millennium and a half is staggering testimony to the welds. They are not just connections, they are perfect continuations of the metal, so seamless that the pillar behaves as a single, homogeneous unit. This speaks to an intuitive, deep understanding of material behavior under stress that feels almost prescient. The smiths knew their iron. They knew how to heat it to precisely the right color, how to hammer it with just the right force to squeeze out impurities, and knit the crystalline grains of the metal together across the joint, without introducing new weaknesses. They achieved a uniformity of strength throughout the entire massive object that our modern, destructive testing would struggle to fault. This physical resilience forms a perfect partnership with the chemical resistance. The passive film protects the surface from corrosion that could pit and weaken the metal. In turn, the flawless, homogeneous structure ensures there are no internal stress points where corrosion could find a foothold and begin its work from the inside out. Each form of mastery defends the other. The pillar, therefore, is not merely strong or merely rust-proof. It is a holistic system of preservation, a perfect storm of ancient insight where material science and structural engineering were two sides of the same coin. Its continued straightness, its unwavering verticality against the sky, is a silent, powerful declaration. It tells us that the builders did not just hope their work would last, they engineered every aspect of it, from its atomic bonds to its macroscopic form, with the absolute certainty that it would. That flawless structural integrity came at an immense price, one measured not in coins, but in the sweat and resources of an entire civilization. Forging the pillar was an industrial undertaking of staggering scale, a project that would have drained the wealth of a lesser society. First, consider the fuel. The bloomery process is incredibly inefficient, requiring vast amounts of charcoal to produce a relatively small amount of workable iron. Experts estimate that to produce the pillar's 6 tons of finished metal, the Gupta smiths would have needed to burn through something like 30 tons of charcoal. This was not simply gathering firewood. Producing high-quality charcoal is a skilled craft in itself, requiring carefully managed kilns and acres of managed forest. The sheer volume suggests a highly organized system of resource management, a supply chain stretching from woodland to forge. Then there is the ore itself. We now know it was a specific high-phosphorus ore, likely sourced from particular mines. Transporting tons of this heavy rock to the workshop site, before the age of carts or paved roads, was a logistical feat involving animal power and human labor on a grand scale. And this all precedes the actual forging. The work required teams of the most highly skilled, supported by apprentices, laborers to manage the bellows and move the hot metal, and overseers to coordinate the entire symphony. This was not a side project. It would have been a full-time, capital-intensive operation lasting for months, possibly even years. The economic meaning here is profound. A society can only dedicate such enormous resources, materials, and elite labor to a single, utilitarian object if it is already secure, wealthy, and stable. The pillar is not a tool for farming or a weapon for defense. It is a symbol. Its very existence is a declaration that the Gupta Empire had moved beyond mere survival. It had a significant economic surplus, a complex administrative system to marshal these resources, and a ruling class confident enough to invest that surplus not in immediate needs, but in a permanent monument to their own power and piety. The pillar, therefore, is far more than a metallurgical sample. It is a physical audit of a golden age. Its iron embodies the agricultural bounty that fed the workers, the health of the forests that fueled the forges, the sophistication of the trade networks that supplied materials, and the authority of a state capable of orchestrating it all. When we look at it, we are not just seeing ancient science, we are seeing the concentrated economic output of one of history's most brilliant civilizations, cast into a form meant to outlast them all. This realization shifts the mystery from how they built it to why they could, framing its silent endurance as the ultimate symbol of a society at its peak. This solitary sentinel of iron forces a difficult question upon us. If the artisans of the Gupta era possessed knowledge so profound it allowed them to forge a pillar for the ages, what else might they have known that has since slipped through the cracks of history? The Delhi pillar stands as the most compelling evidence for what scholars call the lost knowledge hypothesis. This is the unsettling idea that human understanding does not always march forward in a straight, unbroken line. Instead, it can be a flickering flame, brilliant in one era, only to be snuffed out by the winds of social upheaval, war, economic collapse, or simply a shift in cultural priorities. The specific recipe for this iron, the precise balance of ore and process, was not a secret written down in a manual. It was a living craft, passed from master to apprentice through demonstration and practiced hands. When that chain of transmission was broken, perhaps by invasion, by the decline of the royal workshops that funded such projects, or by the simple migration of skilled communities, the knowledge could vanish in a generation. It becomes a ghost in the historical record, leaving behind only its physical creations to haunt our assumptions. The pillar is a stark, silent rebuke to the notion that our current technological paradigm is the only possible one, or even the most advanced in every respect. It suggests that ancient innovators, working through meticulous empirical trial and error over centuries, may have discovered elegant solutions to problems we are only now beginning to retroactively explain with our modern scientific language. They operated in a different framework, one where intuition, deep observation of materials, and a generational dedication to craft could yield results that appear miraculous to us. Think of it like a library where the books are written in a forgotten language, and all we have left are a few indestructible book covers. The pillar is one such cover, beautifully made and perfectly preserved, but the pages inside, the full context of the knowledge that created it, have turned to dust. This realization is not about romanticizing the past, but about humbling our view of progress. It asks us to consider how many other branches of practical wisdom, from medicine to agriculture to architecture, may have once reached heights we cannot see from our vantage point, simply because their greatest monuments were made of less enduring stuff than iron. The pillar's endurance, therefore, is a double-edged gift. It gives us a tangible marvel to study, but it also whispers of all the marvels we have lost, reminding us that the story of human ingenuity is filled with forgotten chapters waiting to be rediscovered. Its endurance as a physical object is matched only by its journey into the national imagination. Today, the Delhi Iron Pillar is far more than an archaeological find. It lives as a powerful symbol, instantly recognizable across India and to historians worldwide. You can find its elegant silhouette gracing postage stamps and the pages of school textbooks, a quiet ambassador of a profound legacy. It is not presented merely as an old thing, but as a testament to a specific kind of genius, one that seamlessly wove together scientific inquiry, artistic expression, and spiritual depth. This iconic status transforms its role completely. The pillar is no longer a passive relic to be analyzed. It has become an active participant in a living conversation. For artists, its sleek form and ancient script are a muse, representing timelessness and resilience. For writers, it is a character in itself, a silent witness whose story can frame narratives about history, memory, and human ambition. For modern engineers and metallurgists, it is both a benchmark and a mentor, a challenge from the past that continues to inform research in corrosion science and sustainable materials. Its very image evokes a dual sense of pride and profound curiosity. It serves as a physical anchor, a tangible thread that connects the bustling, technologically driven present of modern India directly back to the innovative spirit of its Gupta-era ancestors. This cultural resonance is not a secondary detail. It is essential to the pillar's ongoing life. Because it is cherished as a national icon, it commands continued attention, funding for its preservation, and a stream of fresh questions from each new generation of scientists and scholars. This public value ensures its protection far more effectively than any academic paper alone ever could. The pillar thus escapes the fate of a static museum piece. It breathes within the culture, evolving from an inert artifact into a living symbol. It participates in contemporary dialogues about national identity, asking what it means to build a future that honors such a sophisticated past. It sparks discussions about the nature of innovation itself, reminding us that groundbreaking discovery can wear the humble guise of wrought iron and emerge from the rhythm of a hammer. In this way, the pillar achieves a second kind of immortality, not just in its metal, but in the mind of a nation, forever linking a glorious past to an inquisitive present. Even the most resilient guardian has its vulnerabilities in the modern world. For all its centuries of defiance, the Delhi Iron Pillar now faces a new and insidious enemy, one its creators could never have foreseen. The greatest threat no longer comes from monsoon rains or seasonal heat, but from the very air of the city it has watched over for so long. Delhi's infamous smog, a thick haze of industrial and vehicular emissions, carries a chemical cocktail that could slowly undermine the pillar's ancient defenses. Of particular concern are sulfur compounds. When sulfur dioxide in polluted air mixes with moisture, it can form weak sulfuric acid. This acid rain, though dilute, has the potential to slowly alter the chemistry of that precious passive film. Over decades, this constant, low-level acidic assault could theoretically degrade the stable iron phosphate layer, making it less effective at blocking corrosion. It is a silent, incremental threat, a battle of attrition waged molecule by molecule against a 1,600-year-old sentinel. Alongside this atmospheric challenge is a more tangible one: the sheer weight of human admiration. Millions of visitors now pass through the complex each year. While the old tradition of trying to encircle the pillar is now prevented by a protective fence, the cumulative effect of vibration, increased humidity from breath, and even the micro-abrasions from dust carried on clothing all present a modern form of wear. The very love and curiosity the pillar inspires now necessitate careful management. This places conservationists in a profound ethical and scientific dilemma. Their goal is to protect the object, but they must ask, protect it from what and into what state? The pillar's longevity is the result of a specific, long-term relationship with its environment. If we seal it in a glass case or pump in inert gases, we would be removing it from the very conditions that forged its legendary resistance. We might save the iron, but we would end the experiment. We would freeze it in time, severing its ancient dialogue with the world. The current approach is one of minimal, intelligent intervention. Scientists employ invasive monitoring, using sensors to track vibrations, temperature fluctuations, and air quality right at the pillar's surface. The protective fence maintains a necessary boundary while allowing the monument to remain in its rightful place under the open sky. Research continues into exactly how modern pollutants interact with the ancient film, providing data to inform future decisions. The mission is no longer just to understand the pillar's past, but to steward it through a new geological age, the Anthropocene, where human activity is the dominant environmental force. It is a deeply ironic task. We now must use our advanced science, our spectrometers and environmental models, to safeguard the legacy of an older, perhaps equally sophisticated science. We are applying our hard-won knowledge to preserve the proof of a different kind of knowing. This ongoing effort transforms the pillar from a static wonder into a living classroom. It teaches us that preservation is not about stopping time, but about careful, respectful accompaniment. It asks us to be humble guardians, using our tools not to dominate the past, but to listen to it, ensuring that its silent, metallic story continues to whisper to the centuries still to come. 16 centuries of silent endurance ask us to reconsider the very shape of history itself. We often picture technological progress as a single, unbroken line, a steady climb from simple tools to complex machines, with each generation standing on the shoulders of the last. This is a comforting, Western-centric narrative of inevitable advancement. The Delhi pillar stands firmly outside that line. It represents not a step on a staircase we are still climbing, but a breathtaking peak reached in the 5th century, a summit of empirical materials science that we, with all our laboratories, still gaze upon with awe. This forces a radical thought. What if progress is not always linear? What if it is more like a garden where different flowers bloom in different seasons, in different parts of the world, some of which are later forgotten until their seeds are found again? The pillar is the seed of a forgotten flower. Its existence proves that profound mastery can be intensely domain-specific, a deep, narrow valley of expertise cultivated by a particular culture at a particular moment. The Gupta metalworkers achieved something we struggle to replicate, not because they were more intelligent in a general sense, but because their society channeled immense resources, tradition, and need into perfecting one magnificent thing. That convergence of knowledge, material, and purpose created a flash of perfection. But when that specific social and economic context faded, the precise recipe for that perfection could fade with it. The knowledge was not lost because it was inferior. It was lost because it was no longer cultivated. This invites a far more humble and nuanced view of human history. It asks us to see innovation not as a permanent possession, but as a fleeting alignment. A culture might master monumental architecture but not sailing, or develop profound philosophical systems while their metalwork remains ordinary. Mastery is not a permanent state we achieve and hold. It is a brilliant, temporary convergence. The pillar, therefore, is not an anomaly in the story of progress. It is a vital correction to the story we usually tell. It reminds us that many cultures have had their own golden ages, their own peaks of understanding that did not necessarily lead directly to our present. Their achievements are not primitive precursors to our own. They are complete and sophisticated answers to the questions their world posed. To stand before the Delhi iron pillar is to stand before a different kind of mirror, one that reflects not our superiority, but our shared, fragile capacity for moments of sublime genius. It whispers that the path of human ingenuity is not a single road, but a vast, branching network, with some paths worn smooth by time and others, like the one that led to this rust-proof iron, overgrown and waiting to be rediscovered. This distinction between knowing how and knowing why is the quiet heart of the pillar's lesson. It forces us to separate two powerful, yet fundamentally different, kinds of human understanding. On one hand, we have theoretical science, a framework built on abstract principles, mathematical models, and a quest for underlying causes. It seeks to explain the universe in a language of laws and mechanisms. On the other hand, we have empirical knowledge, a wisdom rooted in the hands, the eyes, and the accumulated experience of countless trials. This is the knowledge of the craft tradition. The Gupta era almost certainly did not have a concept of the periodic table. They would not have spoken of phosphorus atoms influencing electron transfer at the metal's surface. Their genius operated in a different register. They knew, through generations of observation, that the dark, heavy ore from a specific region, when smelted with charcoal from a particular wood, and worked with a precise sequence of heats and hammer blows, yielded an iron of extraordinary character. They could feel it in the way the metal moved under the hammer, see it in the color of the sparks, and witness its endurance over a lifetime. This was a deep, intimate familiarity, a conversation with the material conducted through practice and perfected through repetition. It was a technology of the senses. The pillar is the ultimate proof that this empirical path is not a lesser one. It can lead to results of breathtaking sophistication and durability. A master chef may not know the molecular chemistry of a reaction, but they know precisely how to sear a steak to perfection every single time. In the same way, the ancient smiths mastered the recipe for immortality in iron without needing the theoretical cookbook. This is not to say one form of knowledge is superior to the other, but to recognize they are complementary forces that have often advanced on separate tracks. Our modern world is built on the marriage of the two, where theory guides experiment and practice validates models. The Delhi pillar represents a pinnacle reached almost entirely by the empirical path. It stands as a monument to what is possible when human attention is focused, generation after generation, on perfecting a single craft. It challenges our modern bias that values the abstract explanation over the tangible result, reminding us that some of history's most enduring answers were found not in a laboratory of the mind, but in the heat and smoke of the workshop. That ancient conversation between iron and atmosphere has become a modern blueprint. The passive film protecting the Delhi pillar is not a historical curiosity, it is a foundational principle. Today, we fight corrosion using methods that echo this 1600-year-old innovation. Galvanization coats steel in a layer of zinc that sacrificially corrodes to protect the metal beneath, thickens the natural oxide layer on aluminum into a hard, protective shell. Stainless steel alloys introduce chromium, which forms its own thin, stable oxide film the instant it is exposed to air. Each of these is a human-made version of what the pillar achieved naturally, a deliberate engineering of the surface to create a barrier. Scientists now look at the pillar's specific film, its iron-hydrogen phosphate structure, with more than academic interest. They ask if its unique chemistry could inspire a new generation of smarter, more resilient coatings. Imagine a paint for bridges or the hulls of ships that doesn't just act as a barrier, but actually heals minor scratches by reacting with moisture in the air, mimicking the pillar's self-maintaining property. Research into such bio-inspired and ancient-inspired materials is a growing field, and the pillar serves as its oldest and most successful case study. It provides a real-world, long-term data point that no accelerated lab test can match. This shifts the pillar's role from artifact to active collaborator. It proves that extreme longevity in metals is not a fantasy, it is an engineering goal with a proven precedent. By studying it, modern researchers are challenged to recalibrate their timelines. We typically design infrastructure like bridges or pipelines for a service life of perhaps 100 years. The pillar, standing for over 16 times that duration, redefines what is possible. It encourages material scientists to think in centuries, not just decades, to pursue sustainable design that minimizes the constant, costly cycle of repair and replacement. The pillar's legacy, therefore, is not locked in the past. It is actively pushing the boundaries of our future, proving that sometimes the most advanced path forward begins by looking back at a solution that has quietly, defiantly worked all along. The iron's conversation with the modern world has entered a new digital dimension. While the pillar itself remains rooted in the soil of Delhi, its essence is now traveling at the speed of light. Advanced technologies are granting us a kind of X-ray vision, allowing for intimate study without a single touch. Teams now use three-dimensional laser scanning, where millions of precise laser points map every curve, every character of the ancient inscription, and every subtle imperfection on the surface. This creates a perfect digital twin, a virtual replica accurate to within millimeters. This model is far more than a simple picture. It becomes a tool for profound structural analysis. Engineers can simulate stresses, model the effects of seismic activity, or even visualize internal structures inferred from surface data, all within the safety of a computer. It is a form of virtual preservation, ensuring that the pillar's exact geometry is captured for all time. Alongside these scans, ultra-high-resolution photography captures the surface in stunning detail, revealing textures and patterns invisible to the naked eye. These vast collections of data are then curated into online databases and virtual museums, accessible to anyone with an internet connection. A student in Brazil, a historian in Japan, or a curious enthusiast in Norway can now examine the pillar's inscription or study its form from angles impossible to achieve on-site. This digital immortality creates a powerful safeguard, a backup copy of history. Even in a hypothetical scenario where the physical pillar faced an unforeseen threat, its precise digital record would endure, allowing future generations to continue the investigation. More than just preservation, this process democratizes the mystery. The pillar is no longer the exclusive domain of those who can travel to Delhi or gain special research access. It belongs to a global community of minds. This online collective can pore over the same high-fidelity data, share observations, and propose new theories, blending cutting-edge digital tools with the ancient physical craft they seek to understand. The pillar, a product of 5th-century hands, now lives simultaneously in the physical world and in the cloud, inviting a new era of collaborative wonder to unfold around its timeless form. That digital replica captures every minute detail, including a truth often lost in the legend. The pillar does, in fact, show signs of corrosion. Look closely near its base, where moisture from the ground persists longest, and you will find a subtle texture of minor pitting. Its entire surface is sheathed not in bare, shiny metal, but in that dark, stable patina. This is the crucial, beautiful nuance. The Delhi pillar is not magically immune to the laws of chemistry. Instead, it represents a supreme mastery over them. The ancient metalworkers did not prevent corrosion, they guided it. They engineered the iron to corrode in one specific beneficial way, forming that thin, dense film of iron hydrogen phosphate. This film is itself a form of corrosion, but it is a protective skin, not a destructive disease. Think of it like the difference between a healthy scab that forms over a clean cut and seals it, versus a severe, infected wound that spreads and worsens. Common rust is like that infection. It is flaky, porous, and voluminous. It cracks and spalls, constantly exposing fresh metal to attack, eating away at the structure from the outside in. The pillar's film is the perfect scab. It is adherent, porous, and so stable it actually stifles the very process that created it. This is the genius, the shift from myth to profound science. The achievement is not a defiance of nature's rules, but a brilliant negotiation with them. The artisans convinced the iron to use its first reaction with the atmosphere to build its own perfect, permanent shield. This distinction elevates our understanding. It moves the story from a tale of impossible magic to one of elegant, observable engineering. The pillar's true lesson is about control, not escape. It shows us that sometimes the path to immortality is not to avoid a process, but to understand it so deeply that you can direct its outcome toward preservation. This subtle reality makes the accomplishment more impressive, not less. It was not an accident of perfect material, but the deliberate cultivation of a specific chemical relationship between that material and the world. The pillar stands not as a rebel against time, but as a wise collaborator with it. That digital immortality is built upon a far older human network. The pillar's true material was not just iron, ore, and charcoal, but the coordinated effort of an entire civilization. Forging this single object was a social symphony, demanding dozens of distinct, highly specialized roles to perform in perfect harmony. First, miners had to locate and extract the specific high phosphorus ore, understanding through experience which rock would yield the right metal. In forests far from the mines, teams of charcoal burners managed precise kilns, transforming wood into the pure, high-heat fuel required for the bloomery furnaces. At the forge site itself, a hierarchy of labor came alive. Furnace tenders maintained the temperatures, reading the fire's color and roar. Master blacksmiths directed the entire operation with an intuitive knowledge of the material's behavior. They were supported by teams of hammerers, whose strength and rhythmic blows shaped the glowing metal, and by apprentices who learned the craft through observation and assisting with countless smaller tasks. Overseeing it all were administrators and patrons, likely connected to the royal court, who secured the resources, managed the logistics, and ensured the project stayed true to its monumental vision. This was not a casual workshop effort. It was a state-sponsored, industrial-scale undertaking. The sheer number of people involved, each a specialist in their own right, points to a society with a complex, stratified economy. It had moved beyond subsistence, generating enough agricultural surplus to feed this farming workforce and support their dedicated crafts. The metallurgical knowledge itself was not public information. It was likely guarded within guild-like structures, passed down from master to apprentice in closely held traditions. This concentration of skill created centers of excellence, but it also made that knowledge vulnerable, dependent on unbroken chains of mentorship. The logistics alone are staggering to consider. Coordinating the flow of ore from distant mines, charcoal from managed woodlands, and food and tools for the workers required a sophisticated administrative system. Someone had to plan the sequence, from the first strike of a miner's pick to the final, ceremonial erection of the 23-foot column. This level of project management hints at a bureaucracy capable of long-term planning and resource allocation on a grand scale. So when we admire the pillar's rust-proof surface, we are seeing more than a chemical achievement. We are seeing the physical imprint of human cooperation, of social hierarchy, and of organized knowledge transmission operating at its peak. The pillar stands as a monument not only to a king or a god, but to the silent, collective genius of the countless unnamed hands that conceived, extracted, forged, and raised it. Its endurance is a testament to what a society can build when it aligns its resources, its specialized labor, and its ambition toward a single, timeless goal. The pillar's perfect physical form may have been designed for a skyward conversation. In the Gupta era, astronomy was not a separate science. It was the very language of time, ritual, and cosmic order. Scholars meticulously charted the movements of planets and stars, developing sophisticated calendars and mathematical models. Could this celestial knowledge have been encoded into the pillar itself? Some researchers look at its placement and dimensions with this question in mind. Its original location on a hill named was not arbitrary. Hills were often chosen as sacred observational platforms, bridging earth and sky. The pillar's verticality itself is a powerful astronomical symbol, a fixed axis around which the heavens appear to turn. While no definitive alignment has been proven, the possibility is compelling. Perhaps its height or shadow at certain solstices or equinoxes served as a giant gnomon, a sundial marking sacred time. This would fuse its function as a religious standard with a practical, observational role, making it a true axis, a world pillar connecting terrestrial power to celestial cycles. This line of inquiry asks us to see the monument not just as a thing, but as a participant in a cosmic dialogue, its iron form silently measuring the passage of epochs under the same stars its builders watched. This celestial dimension finds a parallel in a more esoteric tradition, the ancient practice of. This was not mere proto-chemistry, it was a spiritual and material science aimed at transformation, longevity, and the attainment of perfection. Alchemists sought to transmute base metals into noble ones, and in a broader sense, to purify the human body and consciousness. Within this framework, the creation of the Delhi pillar takes on a resonant symbolic meaning. Here was a massive, earthly material, iron, subjected to the transformative fires of the forge and the skilled hands of the smith. Through a rigorous, almost ritualistic process, it was purified of weaker elements, its slag impurities hammered out, and its structure made homogeneous and strong. The result was not gold, but something perhaps more miraculous in a practical sense, a metal that achieved a state of near-eternal resistance to decay. In the pursuit of, this could be seen as the ultimate success, the transformation of a base substance into a form of perfected matter, embodying the ideals of purity, stability, and immortality. The pillar, therefore, might be interpreted as a monumental expression of this philosophy, a physical testament to the belief that through disciplined knowledge and process, one could achieve a state of enduring perfection. It stands as a bridge between the workshop and the temple, between the hammer and the hymn. While these connections remain in the realm of scholarly interpretation, their value is profound. They encourage us to step back from a purely technical analysis and view the pillar within the full richness of its intellectual and spiritual climate. In the Gupta worldview, the pursuit of understanding was holistic. Astronomy informed ritual, mathematics served architecture, and the manipulation of materials could be a path to spiritual insight. The pillar refuses to be categorized neatly as just an engineering feat or just a religious icon. It comfortably inhabits both realms, suggesting its creators did not see a hard division between them. To see it through this integrated lens is to appreciate a different mode of innovation, one where the quest to master the physical world was inseparably linked to a quest for cosmic and spiritual truth. The iron's defiance of rust then becomes more than a metallurgical curiosity. It becomes a symbol of a civilization's desire to touch the eternal, to create something in the material world that resonated with the timeless order they perceived in the stars above. This perspective does not diminish the scientific achievement, it deepens its cultural meaning, framing the pillar as a singular point where heaven, earth, and human genius were forged, quite literally, into one enduring whole. That celestial and spiritual resonance finds a very modern, very tangible echo in the foundries and research labs of today's India. The Delhi pillar is far more than a relic in a tourist guidebook. It has become a foundational story for a nation reasserting itself as a global industrial power. In boardrooms, engineering campuses, and government policy documents, the pillar stands as a powerful symbol of indigenous technical genius, a proof of concept that is over a millennium and a half old. It provides a deep historical root for contemporary ambition, transforming national pride from a vague sentiment into a specific metallurgical inheritance. When a modern Indian metallurgist looks at the pillar, they are not just looking at history, they are looking at a direct ancestor in their field, a silent mentor whose very existence declares that advanced material science is part of their cultural DNA. This legacy is actively cultivated. Prestigious institutions like the Indian Institutes of Technology and National Research Laboratories often reference the pillar in their outreach and curricula. It is presented not as a mysterious anomaly, but as evidence of a long, sophisticated tradition of inquiry and craftsmanship. For a student embarking on a career in materials engineering, this is profoundly empowering. It frames their modern studies not as the adoption of a foreign science, but as the continuation of a homegrown intellectual lineage that was once the envy of the world. The psychological impact is immense. It counters any narrative of technological dependency by providing a stunning counterexample from the deep past. It says, "We were masters of this craft when much of the world was in a different age, and therefore we can be masters again." This connection is consciously drawn in initiatives promoting advanced manufacturing and cutting-edge materials research. The pillar embodies the ultimate goals of modern industry: durability, sustainability, and flawless performance, but achieved through ancient means. It challenges today's engineers to match that longevity with their own creations, to build infrastructure and technology that can last for centuries, not just decades. In this way, the Iron Sentinel does not belong to the past alone. It is a silent partner in the nation's future, a constant reminder that the highest forms of innovation are not about forgetting where you came from, but about understanding that legacy so deeply you can build upon it for the world to come. Even with its secrets partially unlocked, the pillar still guards profound unknowns. The precise geographical fingerprint of its ore remains a tantalizing mystery. Was it sourced from a single, now exhausted vein, or from several mines across the Gupta realm? Pinpointing that origin could lead us to the very workshop site, perhaps revealing fragments of other projects, tools, or even failed attempts that would tell us so much more about the scale and methods of this industry. Beyond its birthplace, we can only speculate about its potential fate elsewhere. How would this specific iron behave in the salty, corrosive air of a coastal environment or in the freeze-thaw cycles of a northern climate? Its resilience is a product of a specific dialogue with Delhi's weather, a partnership we do not fully understand. The path forward for research lies in ever more delicate listening. Future studies may employ advanced ground-penetrating radar or ultrasonic tomography to non-map the internal architecture of those ancient welds, revealing the ghostly seams where master smiths fused the giant together. Long-term environmental sensors could continuously monitor the microclimate at its surface, creating a live data stream of how temperature, humidity, and modern pollutants interact with the ancient patina, allowing scientists to model the film's stability for centuries to come. These are not just technical challenges, they are open invitations. Every unanswered question ensures the pillar is never relegated to a closed chapter in a textbook. It remains a vibrant, living subject of inquiry, a singular puzzle that draws historians, archaeologists, chemists, and materials engineers into a rare, collaborative conversation. Their shared goal is not merely to solve a historical riddle, but to engage in a continuous dialogue with a masterpiece, ensuring that its silent, metallic story keeps generating new questions for generations yet to come. 16 centuries of silent testimony have brought us here. The Delhi Iron Pillar is far more than a rust-resistant artifact. It is a profound statement etched in iron about the very nature of human ingenuity. Its enduring presence on the landscape of history challenges a subtle but powerful assumption we often carry: the idea that older necessarily means more primitive, that our current understanding is the pinnacle of a straight, upward climb. This chronological snobbery falters before its dark, unyielding surface. The pillar stands as a quiet rebuke to that timeline, proving that flashes of sublime mastery can illuminate any age, and that the path of knowledge is not a single road, but a vast, branching network with many forgotten trails. It demonstrates with absolute clarity the staggering power of empirical mastery, of knowledge earned not through abstract theory alone, but through generations of hands-on dialogue with fire, ore, and hammer. In its flawless welds and self-healing skin, we connect directly to the minds of ancient innovators. We are not looking down on their work from a height of modern superiority. We are looking across the centuries at peers who solved a monumental problem with an elegance that still inspires awe. From the specific chemistry of its forged iron to the intelligent barrier of its protective film, from the poetic ambition of its Sanskrit inscriptions to its modern weight as a national symbol, the pillar weaves an inseparable tapestry. It shows us a world where science was not separate from art, where engineering served faith, and where a quest for material perfection was also a spiritual pursuit of the eternal. As we reflect on this old marvel, let it reshape our own perspective. Let it remind us that true greatness is not defined by the era in which it is born, but by the timeless, universal pursuit of excellence. It asks us to look at the wonders of our own time and consider, what are we building that will whisper our story to the people of the year 3600? What legacy of ingenuity, woven from our own values and knowledge, will we leave standing in the open air for the centuries to question and admire? The pillar's lesson is ultimately one of humility and hope, a silent encouragement to build not just for now, but for the long conversation with time. If this journey into ancient mastery has sparked your curiosity, consider subscribing for more explorations into history's greatest puzzles. And we would love to hear your thoughts. What aspect of the Delhi Iron Pillar's story resonates most with you? Share your reflections in the comments below.